Hey everyone, welcome back to the AI Nation podcast. The podcast is all about the German AI startup scene. In this episode, I'm really excited to talk with Bertrand from Pruna AI. He's the chief scientist, founder, and president, and they're on a mission to make AI accessible for the people and sustainable for the planet. Pruna AI's technology enables 4 to 10 times model compression without major accuracy loss. I'm really interested in what he has to say about entrepreneurship and the future of AI. Let's go. Bertrand, your academic background spans from mathematics to machine learning and uncertainty quantification. What initially drew you to that intersection of that disciplines?
That's a very good question. So that's completely correct. So I studied a lot of mathematics and also had the opportunity during my studies to also study physics, which gives a lot of inspiration for actually machine learning models and so on, if you know about diffusion models, for example. And at some point, basically, I was really interested to understand a lot, the logic behind, how the world works, how the data works and so on. So it was kind of a key motivation to go into the directions of, data science, machine learning, trying to understand a bit like how to use all of this data that is offered to us.
That's so interesting. And then after that, you've decided to do some research, right? Can you tell us a little bit about the journey starting research? How did you get started? What did you do there? What was your mission?
Okay. Very, very good question. So I think maybe to take a step back. So I was really starting to first my study in France and starting to do some research, some early research here after just my master, and studying a lot of things regarding how graphs and networks work, which is really important for social media. For example, we have like a lot of social networks and so on. And this was really interesting to me because I had before like kind of previous experiences, let's say larger companies. You can imagine like very large companies where all the processes are a bit slower and so on. And in research, you can be very active, decide on what you work, decide on the key problems that you're interested in. And I had this freedom that allowed me to just explore a lot of things. So this was kind of the first research I did, and motivate me to start a PhD so I decided to do it in Munich, in Germany, at the Technical University of Munich, because there was a lot of work about graphs and done actually in Munich with Stefan Günnemann, who was my PhD supervisor and was is still like one of the most well-known researcher about this, about like graph neural networks and so on. So it motivated me to join there. Then the question is, when I joined for the PhD, you have also to decide what would be the topic. It should not be too broad, not be too narrow, just the right level to find what is an interesting area where you can provide some new contributions. And one problem that was really important was how much you can trust machine learning models. Usually machine learning models, they do some predictions. For example, they would say, okay, for self-driving cars, they would say, okay, there is an obstacle or there is not an obstacle. But what you are also interested to know is how sure the machine learning model is about this prediction. Because it can have dramatic consequences. If it does not detect an obstacles, you can imagine what are the consequences.
Of course.
And one key element for this is to have the model being able to estimate how sure it is, so the uncertainty estimates about the prediction it does. So this was kind of the key motivations to start doing a lot of research during my PhD about uncertainty estimation for machine learning models.
That's so interesting, and I agree to you. Like, this is probably the base for what's happening right now, right? Like, those are the questions when you want to implement AI in real life. Those are one of the most important questions you need to answer. I've read that you've authored almost 30 papers. You've got nearly 1,000 citations. Do you want to talk about that a little bit? Like, what were your research projects and what were the papers that you were interested in the most? How did it help you to find a problem that later has been solved by Pruna AI?
So that's a very interesting question. So I think the PhD is the perfect phase to explore a lot of things. And all these papers that I've been writing, not alone, with a lot of collaborators that have been helping a lot for sure. All of these papers, all of this project allowed me to explore different, areas. And there have been like a couple of areas. One of them is, for example, uncertainty estimation. So to have reliable machine learning models. Another area is kind of like efficient machine learning models. That was kind of motivating also like the concept behind Pruna, so to say, to make machine learning models more efficient, but also like some other topics like more being able to handle different types of data. So there are some types of data which are called independent, which are kind of easy to handle, for example, images or tabular data. But there are also some data like which are called non-independent, like graphs, nodes in a graph, like node in a social networks, user in a social network that influence each other and so on. So this is like another kind of area where I've been doing a lot of research. And maybe to explain a bit the connection between these different areas is, for example, I started with reliable machine learning and looking at uncertainty estimation. But one key problem when doing a lot of this project was I was requiring a lot of resources, compute resources, to do my experiments. And it's always a bit of fight between people using the same cluster to get the compute access. And this is definitely something which is important. So a lot of my papers, they were focusing on making uncertainty estimation efficient so that you don't have to fight for having reliable models. And then I realized, okay, it's important to have reliable models, but actually for most people, the first problem is not reliability, but first getting the models running within their budget, their compute constraints. So that's why I moved a bit toward more, efficiency in machine learning and and starting to do some research more on efficient machine learning models.
That's such a great insight. Like I didn't even really think about it, but of course, yeah, like the compute, like it's only got limited H100s, right? And especially in Europe, I think it's really hard to, if you want to have like something that needs a lot of compute, like to find the cluster cluster of compute that does the action for you, right?
Yes. Maybe one thing I can say on this, if I can,
of course,
is one fun story is at some point I was just writing a research paper. I think it was a posterior network paper on natural posterior network. And I just wanted to estimate how much compute does it cost to just write this single paper of experiments. And to just making some estimations, I was thinking I can do it on my own with just my laptop probably, but actually it costs like 10k euros just to make a single paper, which is not a large paper. And then I was comparing with Google papers and so on, and sometimes they say in the abstract, this paper costs like 1 million or millions of euros, So it's like compute is really important on this, and just making quick estimations, you can realize this. So that's crazy, I think.
That's really interesting. From your perspective, like DeepSeek R1 just got released and everyone is rumoring around that they've used way less resources to compute it, right? It's going in also that direction. What's your impulse when you think about that?
So I have a lot of thoughts about DeepSeek. So I think first that's great that there has been like this DeepSeek model showing that making some part of the machine learning lifecycle more efficient is possible. But one thing is that sometimes for the public audience, there might be some confusion of what has been made more efficient. So usually there is the training phase, which is very costly, but there is also the inference phase, which is when you deploy the model and then it just runs and provide a service to a lot of users. And what DeepSeek managed to do is to make the training, the first phase, very efficient. So instead of costing 100 million to train a models, they managed to train a single model with 5 million, a bit more than $5 million. But still a lot of research, a lot of people working on it. So definitely still not very easy. But the final model itself is still very huge. I think it's the largest open source model you can find at the moment. So I don't know, it's like almost 800 gigabytes. So it's something you would need 10 H100 to fit like a single model in a naive way, or and run it. So I think DeepSeek is definitely important. They managed to make like nice combinations of methods and make it work to have training efficient, but it's a first step to go more into lean machine learning models for sure.
Would you say it's a real architectural innovation that they've managed to pull off?
I think the main novelty does not come from the new architectures or new thing or new algorithms and so on, because all these algorithms, they existed before. So mixture of experts, this was well known before. So Mistral did a mixture of experts, I think even last year and so on. The distillation, it's very old. Even years before the beginning, I started my PhD, I think it was existing like probably 10 years ago. I don't know. Also, policy like GRPO, they created it in another paper before. So in the end, none of this individually is very new. But I think the main part, which is really brilliant, is how to make this happen together and in a scalable way. So it requires a lot of engineering efforts to use these methods properly and combine them and make it work in a very reliable way.
I also think it's really interesting to see that the base research is like from the 60s, 70s sometimes, right? All right, we've had some other innovations like the Vaswani paper in 2017 with the transformers, but still, like back then there was not the computing power there to test it and to refine like how to implement it. And now we've got all that big data centers and the compute that is necessary to do the next step and to implement. And new challenges come up, even though like the base concept is really old. And it's very interesting to see how the companies do that right now. And it's a lot happening because of the base research that has come before. Like it's exponent. That's why it's exponential, right?
Yes, exactly, completely. As you mentioned, like the base research exists for quite some time, but then it needs some time for people to kind of get the limits, get how to work with this. Transformers is actually now pretty old in the AI space because it moves fast, right? And so if you check the architecture of DeepSeek alone, I think it's not that far from a standard Llama models, so to say, right? But yeah.
Yeah. Maybe let's get a little bit closer to PrunaAI. So
Sure.
during your time, like you've done your PhD at the Technical University in Munich, right? I've seen you've got a summa cum laude, right?
Yes, that's
Congratulations on that. Like it's really hard. Like I want to put that out for all of our listeners and watchers. Like this is really, really, really hard. And you've been at Stanford University as a visiting researcher, right? Was there a particular research breakthrough that planted like the seed of PrunaAI?
So I think my stay at Stanford was more focused on a lot of things regarding uncertainty estimation projects. So it was with Michael Korendorfer, like the lab of Michael Korendorfer, and they do a lot of great work on reinforcement learning, which is very important also for training recent large language models, but also to work with robots and so on. So it was more like in terms of research project, it was really more a focus on uncertainty estimation part, not that much on efficiency. I think something that probably influenced me a lot is kind of just the atmosphere that you get at Stanford when going there and just checking all these huge companies that just started exactly at this place, discussing with people and getting a lot of interesting, conversations, discussions, also just going at reading group and so on. And it just infused in me kind of, and got a bit like the excitement about like, okay, this is how people at the Silicon Valley manage to create startup or future people that will do startups. So that's I guess one way how Stanford kind of helped to go into the Pune direction. Let's say.
I have a friend also who started a software startup in the Silicon Valley and from Stanford, right? And he told me he's from Germany, and he told me it's a very different culture and like it's very different vibes, and somehow he cannot really explain it, what's different, but there's something different. How would you explain it? Like what's in the Silicon Valley and particularly at Stanford that Germany or Europe doesn't really have?
Mm-hmm. That's a very good question. I think at Stanford, I did I didn't spend years there, but from my experience, let's say, it was more like a taste of just trying and taking more risk, like do not hesitating to try a project and see if it fails or not, right? While maybe in Europe and Germany we are a bit safer on this. While I still think that it's changing a bit, right? So now we get more and more this entrepreneurship, mind and so on. So I think this is the main thing is really be able to take risk there. Because in terms of talents, I can for sure say that we have like a lot of talents in Munich specifically, but also in Europe that are, among the greatest AI researchers. And we can see this also by just checking, okay, Yann Lequin is French. I have to, and for example, manage to get this kind of like American spirit and go in the US and manage to mix kind of the European talent and the American spirit of entrepreneurship.
I completely agree. I think talented entrepreneurs and innovators in Germany, but also like in whole Europe, they have brilliant ideas, but somehow they lack the support and the resources and to bring them really to life and to scale them. And I think you've mentioned one really good aspect. It's the risk aversion. Like that's what I heard the most, that the risk aversion in Europe and especially in Germany is just like so different to the United States or other countries where innovation is rapidly happening. I think that's something we can work on. But I also don't want to be too pessimistic, because I think in the last 10 years, we've seen a huge change in Europe and Germany. And like, not everything is as bad as it seems right now. Like, I think the base has been set like for future growth, and we just have to keep on improving on that particular areas.
Yes, I completely agree. I think it's changing, and we can take some examples of Black Forest Lab, for example. There are like people again from Munich that started at LMU and now created, Black Forest Lab that do a lot of nice image generation models. But there are also some other examples in Europe, like Mistral AI, I guess is the second standard one. But there are many other companies, I think, that show that this different mindset of taking the risk and not being too shy to just try. And if it fails, right, you can just reuse the output of what you've done in another way, kind of be positive in the way that what you will work on will not be completely not used in the later stages.
I completely agree. Like now I'm asking, like, what was the defining moment for you when you realized you needed to start PrunaAI? Like, how did you find the problem?
It's hard to say that it was like a single moment. I think it has been like more thinking for a very long time. Even I think before starting my PhD, I had a lot of thoughts on like having a sustainable impact with my work and so on. So I was thinking, okay, AI, what is the best way to have like a sustainable impact about AI? So one way is to have like AI applications that are sustainable themselves. So for example, trying to use AI to predict some things about weather forecasting and so on. But actually what was interesting is when I realized that my papers was costing 10k euros and a lot of compute, I was realizing, okay, but AI itself is actually not maybe that sustainable. So I need to make some things to make this as efficient as possible, so that the impact of it is not it's not negative on the world. And just starting to do some estimation and understand, okay, it costs 10k euros, but how does it mean in terms of energy? How does it mean in terms of CO2 emissions? How does it mean in terms of time and so on? And when collecting a lot of numbers, then you realize, okay, for example, to generate one high definition images with like, one model from Black Forest Lab, Flux, it will require something like a full battery smartphone energy to just generate a single image. So, there are some companies generating millions of images per day. So you can get the feeling, okay, this is not sustainable in terms of energy and so on. So that was the key motivations, kind of like trying to align the incentives also for the sustainability aspect, and also align them with incentives for the business, because people usually they want to say, okay, I'm fine to make some progress on the sustainability aspect, but I don't want also to lose money. I still want to be competitive and so on. So efficiency is a natural way to align them. So you save time, but you also save money. So that's a great thing with making model more efficient. Let's say.
I'm really impressed by your thoughts now. Back in 2017, when I first got like my personal contact with AI, everyone was saying like that's AI's dirty little secret. Like the resources that it takes to compute, the resources that it takes to run the models.
Yeah.
I think you're really on a really good path. You found the problem. I think it's a huge problem as well. And then you need a team, right? Many founders struggle like with assembling that team. Can you tell us a little bit the story on how you met your co-founders and what happened that Pruna AI got to life?
That's a very good point. So finding the team is definitely not easy, and having the time for doing my PhD, like a lot of time during my PhD, gives like some flexibility to think, okay, what would be a good team? What would be the ideal place to start like a startup? And the best thing to find a team is first to work a bit with some of the team members before. So members from the teams were kind of natural for me. So one of them was my PhD supervisor. I worked a lot, Stefan Gunneman. I worked a lot during my PhD, of course. Another person was John Rashwan, that I actually also supervised during my PhD. He was actually my master student at that time. And so we actually wrote some papers together about like pruning. So I can give some words about what is pruning later if you're interested too. But this was kind of one paper that was actually showing, okay, we know how to make some models more efficient. And the last team member is Ryan Naitmazi. I actually studied with during my studies in France. So we were together during multiple years, and he had like a lot of startup and entrepreneurship experience. Also, he did this in multiple countries in Asia, in India, and so on. So this was really kind of natural to find all these people because I already work with them and try to think, okay, what is the best way? What would be the ideal people to work with? But there have been definitely, sometimes some discussions. Okay, how I can find some more people interested because they need to be able to take the risk, and this is hard to convince when there is still nothing completely built to convince people. Okay, this idea you can spend 5 or more or 10 years of your life and it will work. So this is very hard, especially because all these profiles, they are very high-tech profiles that could also get like super nice job outside, like, super well-paid job.
I just wanted to say that. I just wanted to emphasize that like the opportunity cost for guys like you is like so high. You could earn like ton of cash in cutting edge tech companies. So it's really hard to get them to join a project like that, right? But were they convinced from the beginning? Were there like areas where they said, maybe I don't know, and like you had to find together and build that team?
So I think they were mostly convinced from the beginning, just discussing 1 or 2 times, but it was not so hard because the problem is so clear when you give the numbers, when you give the potential solutions, and that these solutions are possible. You are not creating something which does not exist at all. It's really clear that it's possible. So I think the excitement came pretty quickly from them. One thing for sure is like when discussing with people, we see that some people are really not able to take the same risk, for sure. So some people they would say, sounds cool, but I prefer to have like a safe, a safe day-to-day life, which I can completely understand as well, right? So I think the one thing is to talk with a lot of people because you should not force people to take risks that they don't want to if they don't feel comfortable. That's completely normal as well, right?
Of course. But I have the feeling that when passion beats money, something really great happens.
Yeah, that's a very good point. So the mission is something I think very important. So giving to people the feeling that they would work on something very positive. So usually gives a lot of passion, and if the tech is really interesting behind, also it gives a lot of passion. So these are really key elements to maybe make people forget a bit about like maybe the money, which will not come right away or maybe never come. So this is something, showing some other things that a standard work, let's say, whatever standard means here, like a standard work would provide in like another large company.
I personally think the same. If you're passionate about something, if you have a problem and work from the customer experience through the technology to the product, I think if you've done a good job, the money will follow. If it's created out of passion, you have such an advantage to other people because you do it like kind of similar to a hobby. Like you throw everything in, and therefore the chances that it gets really good are high. And if something is really good, there's value for that in the world, right? And value gets like money is just an exchange of value in my opinion. So like, of course, it is important. It's a tool to pay bills, but it shouldn't be the main goal, right?
Yes, I completely agree. Maybe if I can add one thing is, I think at some point it's great to have a lot of passion, and also to take time at some point to think how to convey this passion as well as possible. Sometimes when we get too excited, we might want to go into, technical details and so on. And for sure, as a researcher, you want to explain how it works. But the idea is really show the value, as you said, show exactly what would be the benefit for the final users, for the other people using what you propose. So completely with you on this point.
Nice. So transitioning from academia to entrepreneurship, I think it comes with a really steep learning curve. I would like to know from you, like, what was the biggest mindset shift you had to make, and how different is the life from before?
I think I even wrote like kind of a blog on this because I think it was really important to understand, what are the things that both life share, and what are the things that are not shared. And something that is common is kind of the experimenting process. So just having a hypothesis, being clear about it, setting an experiment. It can be a business experiment or a scientific experiment. For machine learning, scientific experiment can run very quickly. You just throw things on a server. But for business experiments is more, can take weeks, months. You need to try a campaign of communication, for example, or something like this. And then measuring it, to get the results and see, okay, was it successful or not? So this is something I can say that both things share, having a research background help really to frame the experiment process also in a startup. Now, the things that are more different, I would say, is like, what is the topic of the experiments? When you are a researcher, you do experiments with like, algorithms and so on. You can iterate very, very quickly. When you are in a startup, it's harder to maybe know exactly how to control the experiments, know exactly what you test and so on. There are a lot of confounding factors like that can make things vary. So I would say this is maybe one key difference is like we manage to frame business experience in a solid way that you can trust the output and learn from them. Yeah, I think this is one thing, but there are definitely some other change between the two lives. One thing is, of course, you do a lot of other things outside of the tech when working at a startup. You need to understand like what are the legal implications. You need to understand, human resources implications to understand, okay, how to hire people, how to, give benefits to people and so on. You need to understand, how to conduct customers interviews, how to move forward with them step by step and convince them to buy your product and so on. So there are a lot of other domains. So it's very rich. It's you need to switch from task to task very quickly and have a very global view.
You wear many hats.
Exactly.
So you've talked about like business experiments as well. What were some early technical challenges to build Pruna's optimization engine? Like, how did you navigate that first territory of proving the concept in the first way?
Mm-hmm. So I think one thing is at the beginning, like the idea was to make, and this is still the long-term mission, to make, machine learning just more efficient. But there are, as I said before, there are different phases in machine learning models. There is like training and inference. And the first thing we wanted to build is something that does a bit everything, making training more efficient and making inference more efficient. But at some point, of course, you need to decide, okay, we cannot do everything immediately, especially because the methods to make one or the other more efficient are not exactly the same. So we needed to focus just on making one of them more efficient. And then the choice was really driven by, okay, checking statistics about what people use the most. Training, inference. Actually, inference is like 80% of the compute load in general. So you should focus, on inference. And that was one key decision driven by, a bit technical challenges because these are different methods. So that was like, I would say, like a key decision, to start on something. And then there are some other decision, or okay, there are a lot of compression methods that you can apply to a model. So, okay, which one should I start? Which one is the most efficient? So again, it's just an experiment that you have to do. You just check, okay, which one is the most promising? Which one is the easiest to implement? Which one brings the most benefit? And then we just decided based on this, okay, we'll start with inference, then with that type of compression methods, applying to these models and see how to make it scale.
Can you tell us maybe a little bit about that moment when you were doing that first experiment and you were going out like, wow, it works, like we're onto something?
That's it's hard to again identify one moment. I would say one thing is probably when making this paper about like pruning, we had to study a lot of literature around it and think, okay, what is possible? And when you read these papers, you realize that 99% of a lot of models.
Thanks for joining us for the first part of this episode. We hope you enjoyed the discussion so far. If you're ready to keep the conversation going, part 2 is already available right here in the playlist. We appreciate you listening, and we can't wait to have you back for the rest of the story.